Hey guys, we shall take one more problem on continuous time Fourier series. The problem is determine continuous time Fourier series of x of t is it is it is a sum of two periodic signal. One is sine 2 pi t and the other one is cos 3 pi t, and t is varying from minus infinity to infinity. And also I need to plot its magnitude and phase spectrum. Okay, solution. So what is the first thing I need to do? I need to actually find its fundamental period capital T. I need to find its capital T and I need to find its frequency, fundamental frequency omega naught. Okay, once I get this capital T, omega naught equation is actually 2 pi by T. I can plug this T value here and I can find the value of omega naught. Okay, so first we'll try to get T now. So what is x of T? X of T is sine of 2 pi T plus cos of 3 pi T. You might be knowing actually how to find whether the signal is periodic or not. If the signal is periodic, how do we find its fundamental period? I'm not going to explain in detail, but still I will solve the problem. Okay, if we have more than one signal, addition of more than one signal, I need to find the fundamental period of this signal, and I have to find I need to find T1 for this, I need to find T2 for this. If the ratio of these two are rational, then the signal is periodic, otherwise signal is non-periodic. But in this case, obviously signals are periodic because this is a periodic signal and this is a periodic signal. The ratio we get actually rational. Okay, but still we'll find. So we have to find T1 for this. So how do we find T1? Just equate the coefficient of T with omega 1. Omega 1 is actually 2 pi and coefficient of this T is actually omega 2, which is equal to 3 pi. And what is omega 1? 2 pi by T1, which is equal to 2 pi. And what is omega 2? 2 pi by T2, which is equal to 3 pi. So 2 pi cancels out. I end up with omega 1 is equal to 1 second. And pi cancels out. I end up I end up with T1 1 second. I end up with T2. T2 is 2 by 3 second. Okay, so ratio T1 by T2 is equal to what? 1 divided by 2 by 3, which is equal to 3 by 2. So it's a rational, therefore it's a periodic signal, right? And how do we check for its fundamental period? So its fundamental period T is nothing but LCM of T1 comma T2, right? So the fundamental period of the combined signal T is nothing but LCM of T1 comma T2, and T is equal to LCM of, so first signals is 1 and second signal is T2 is 2 by 3, and this is nothing but LCM of 1 comma 2 divided by HCF of 1 comma 3. So why did I write this? Because LCM of a fraction comma dot is nothing but LCM of numerator of the first number, numerator of the second number dot divided by HCF of denominator of first number comma denominator of second number dot. This is what I did. Numerator of first number, numerator of second number 1 comma 2, denominator of the first number, denominator of the second number is 1 by 3. Okay, so T is equal to LCM of 1 comma 2 is 2 divided by HCF of 1 comma 3 is 1, which is equal to 2. So therefore the fundamental period of this combined signal is 2 seconds. Fine. And what is omega naught? Omega naught is what? 2 pi by T, which is equal to 2 pi by 2. T is 2, so 2 cancels out, it is pi. So omega naught is pi radians per second. Okay. Once we got omega naught, now we have to expand that signal in terms of exponential. I will do that. So what is x of t? X of t is equal to what? Sine of 2 pi t plus cos of 3 pi t, right? So I can write it as x of t is equal to 1 by 2j times e power j 2 pi t minus e power minus j 2 pi t. This is for sine 2 pi t, right? Plus What is cos? It is 1 by 2 times e power j 3 pi t plus e power minus j 3 pi t. Okay, this is for cos 3 pi t. Why? Because e power sin theta is what? 1 by 2j times e power j theta minus e power minus j theta. And what is cos theta? It is 1 by 2 times e power j theta plus e power minus j theta. Okay, now I'll just slightly modify this. X of t is equal to, I'll take this 1 by 2j inside, 1 by 2j into e power j 2 pi t. I have written 2 in a bracket minus 1 by 2j e power j, I'll take minus to the 2, minus 2 pi t plus 1 by 2 e power j 3 times pi t plus e power 1 by 2 times e power j minus 3 times pi t. Okay, as I explained you in the previous problem, what is this? This is actually k, its value is 2, and what is this? X of 2, right? And what is this value? 1 by 2j. And similarly, what is this? K, which is equal to minus 2, and what is this term? X of minus 2, which is equal to minus 1 by 2j. What is this value? K equal to 3, and what is this value? X of 3, which is equal to 1 by 2. What is this value? K is equal to minus 3, and what is this value? X of minus 3, which is equal to 1 by 2. So therefore we have the Fourier series coefficient x of k is, at k is equal to 0 I have nothing, comma, at k is equal to 1 I have nothing, which is 0, comma, at k is equal to 2 it is 1 by 2j, at k is equal to 3 it is 1 by 2, and 0 and dot dot dot, rest of the samples are 0. So, and k is equal to minus 1, I don't have anything, so it is 0. K is equal to minus 2, it is minus 1 by 2j, and k is equal to minus 3, it is 1 by 2, comma, 0 and dot dot dot. Rest of the samples are 0. Okay, so we will plot its magnitude and phase angle. The magnitude of x of k is equal to, at k equal to 0 it is 0, k is equal to 1 it is 0, k is equal to 2. What is the magnitude of 1 by 2j? It is 1 by 2, and what is the magnitude of 1 by 2? It is 1 by 2, and 0 dot dot dot. And similarly this is 0, this is again 1 by 2, this is also 1 by 2, and this is 0 and dot dot. So magnitude is usually symmetric. Okay, and what about phase angle? Angle of x of k is 0, comma, and since this is real number, no phase angle, but this is complex number, it is pi by 2, 0 0 0, this is pi by 2 because it is minus 1 by 2, 0 0 0. Okay, so magnitude of x of k is k equal to, this is k 1 2 3 4 minus 1 minus 2 minus 3 minus 4, so it is 0 1 2, sorry, 0 1 2 3, at 2 3, at minus 2 minus 3, so this is 1 by 2, this is 1 by 2, this is 1 by 2, this is 1 by 2. So phase angle x of k, this is minus 2, this is minus 3, this is minus 4. So at 2 it is minus pi by 2, and at minus 2 it is pi by 2. This is k.